Hey everyone, it's really nice to be here. I can see a lot of familiar faces who have probably heard this talk at least 3 times, so I'm sorry to repeat myself again. But I think performance is quite an interesting topic. We've been dealing with it for maybe the last 6 months at Hive, and it's been a difficult one because it's very cryptic. It's very important, obviously, because users care about it and even business care about it, which is quite unusual. But nobody really knows how to fix it. It's so complicated, it's so complex. We, talk about it all the time, yet we are struggling to actually understand how to get to something relatively useful. So nothing's ever easy, is it? But I'm here to make it a little bit easier, hopefully. Over the last 6 months, we have figured out quite a few patterns that could help you in your application as well. And we also figured out how to measure things relatively painlessly in your React Native applications. So I'll be also showing you how to do that so that you yourself can figure out where the pain points in your app are and can improve it. At the same time, I am here to forewarn about pre-optimization because we made a lot of assumptions at the beginning of our journey about things that might possibly cause issues one day, and that actually made us write code that ended up being problematic, and we had to do one of those huge refactors that take months and months to complete. So I'd like to sort of give you an overview of what we've done in this respect. The main issues that we were dealing with were sort of in 2 categories. The first one was that the application was very slow to load. And then the second one was that once it loaded and the user interacted with it, it wasn't particularly snappy. Especially on older Android devices, it was actually very, very slow. I think the startup time on some Android 6 was like 20 seconds, which you can imagine if you want to turn on a light bulb is not ideal. So we tried to figure out what the weak link is in our application. This is a representation of architecture of React Native, if you can't tell that by this amazing picture. We've got 2 threads. One is UI thread and the other one JavaScript thread, and they are connected by React Native Bridge. And the UI thread is the one that's responsible for the actual rendering things out and doing the native stuff. JavaScript thread is responsible for JavaScript. And React Native Bridge is sort of like a message service between the 2. And we didn't know which one was the slow one, but fortunately there is a relatively easy way of figuring that out. And that is using Performance Monitor. It's something that you will find very easily in the developer menu on your React Native application. And it will look something like this. It will directly appear on top of your application. And the things that we cared most about at that point was seeing the 2 things on the right, which is the UI and JavaScript thread. They should ideally be always at 60 frames per second, because that is that point at which users can't actually tell that something is rendering. But in our case, it was dropping a lot, sometimes to -30. On the JavaScript thread, and it was very obviously connected to bad user experience where things look jagged and slow in animation. So we realized that it is probably the JavaScript thread, which we did not expect, but it was somehow easier for us because we are JavaScript developers first and native developers second. So that really helped us direct us in the direction that we should have gone to. But how do you actually figure out why your JavaScript is slow? In our case, this is our application. It's the dashboard where user lands immediately when they open the app. And this is where they see all their products and their state, etc. And the problem was that it was way too slow. And once it loaded and you could swipe between pages, it was still sort of quite jagged. There is sort of a drag and drop on it as well if you long press one of those cells. And that was slow too. So this was a very complicated component to build, and we really didn't want to build it natively because that would mean that we need to write the code in both iOS and Android for a very complex thing. But fortunately, we realized that we don't have to do it. Looking at the Performance tab, which you can find in React Native Debugger or your Chrome debugging tools, you can measure pretty much anything that the JavaScript is doing. It's true that it's not going to give you accurate measurements about the times, but it's going to tell you what it is roughly doing and what is taking a long time. And this is what it looks like for our dashboard, which is obviously really difficult to read, so I'll walk you through it a little bit. So the first bit that just flashed there is the main application structure, which is relatively slim. Then the next bit is the first rendering of the page. And then everything else is who knows what. But we can see that there is like written update all over it, and we can see that it goes really deep from like the top honeycomb, which is the main component, all the way down to every single cell. And we realized what is happening is that the dashboard is re-rendering over and over and over. And because it's a relatively complex component, it has to do a lot of work. So we realized that state change is a problem, but we had no idea what to do with it. We had actually no idea, like, what it even means, what React does. So I spent some time reading up on how Fiber works and all of that stuff, so I'll give you a TLDR of what I think might be happening. So when something changes, and by that I mean state or props in your application, it will see which render functions needs to be rerun, then it will create a new virtual DOM tree, then it will try to compare the old one and the new one, and at the very end comes the rendering in the UI. But what we found was that through a lot of complex recomputing, we might actually change nothing at the end, like visibly for the user, nothing might change at all, which obviously is a problem, but it was still slowing things down. And so we realized that the key point is that we don't want to make the changes, because if we don't make changes, this whole process will not happen. And if we do make changes, we want to make them very locally. And the ultimate answer to all your problems, whenever you ask, during interview, I always ask, how would you make an app faster? And everyone says, should component update. And that's even in the React docs, so that's fair enough. But the truth is that that's like the unexpected villain in our story, because it actually causes more problems than it solves. So we put it all in our components, and then we removed it all again, because we realized that there was a hidden issue with it. Let me illustrate that quickly. Let's say there is a component, and we've got a name and a value in it. And for some reason, we care about the value changing, but not the name. The other way around. We don't care about the value changing, we care about the name changing. So we add a should component update saying, if the name changes, re-render this component. If the value changes, don't do it. That's fair enough, but in 3 months' time, another developer comes in, and they need to add a description. And they don't realize there is this should component update, and suddenly the app is reporting wrong values for the description, and we start having bugs. In a component that's 10 lines like this, you can obviously see it. But if you've got long nested structures, if you've got 20 props, which is a bad design, but sometimes it happens, it might so happen that this will start causing issues. And it caused so many bugs in our application that we decided to remove pretty much all of them unless there was like a special case. Fortunately, React is very good at figuring out what to update when and what to reconcile and what render functions to run if we work with it well. So let me explain to you quickly what React is doing. Whenever you change a node type, so let's say you switch component 1 for component 2, it will remount the whole structure. So it will discard the whole tree that's underneath this component and build a new one. That's obviously a lot of work. If you change prop on the component or its own state, it will re-render itself, and it will then go to its children to see if it needs to re-render those as well. These work in sort of like on shallow equal basis. So that means if you change a reference or if you change a string, it will re-render. And the important thing to remember about this is that every single change you make propagates to all children, or potentially could. So you want to be really careful about changing something on the top level in case it sort of bubbles through the whole application. So let me quickly illustrate what I meant by those things. Let's say we've got like a wrapper 1 and wrapper 2 component, and based on type, we change them. And if I change type down here from 1 to 2, or something else, it will discard all of its children and re-render the whole thing. Again, in this particular case, it's not such a big deal, but if you have children that are quite complex, it becomes a problem. Similarly, the prop change that we probably all know, if I change some sort of a text, then I will have to re-render the children component. So these are very simple, but actually, I think we all tend to forget about the fact that it works this way. There's also the thing that if you update something on top level and then you pass that prop down throughout your whole tree, everything will update in it. So let's have a look at a few examples of how we used to write components and how we are now writing components so that they use this pattern or this way of working to our advantage. We used to have a lot of this stuff, which is anonymous functions. The problem with anonymous function is that every single time the parent components get rendered, we create a new function, a new reference, and that means that the child function gets rendered. Again, on a button like this, it doesn't matter that much, but if it's on a high level, it will cause re-renders throughout the whole application. And anonymous functions are so easy to use that we had them literally all over the place, so we had to introduce an ESLint rule that is now telling us not to do it. And instead, we can just use a named function, or we can use a class method or something like that. It's a very easy refactor, and it's got huge benefits in terms of performance. Then I assume a lot of people are using Redux, because it's like one of the basic go-tos. And it's great, but it can cause issues that other libraries might not. And the problem is that connect and all of these map functions run every single time you change anything in your Redux store. That means a lot of times. Especially in our case, we've got some 100 reducers, so you can imagine that actions are being dispatched all the time. Something in the state is changing all the time, and even if it has absolutely no bearing on any of this, it will still have to run and figure out whether there is some update in there. And the problem is that if we use merge props or map dispatch to props the way I wrote it here, we will create new references to those functions every single time this is ran, which means that then all of the components are being re-rendered. So instead of using merge props and map dispatch to props as a function, what we want to always do is have map dispatch to props as an object, and then merge the props as if either in sagas or in the component itself. Basically, we want to remove it from this particular part that is run all the time. Equally well, selectors will run all the time. Those are the things, like in map state to props, you need to get some data out of the store. And what we want to make sure is that A, the reference of whatever we're getting out of the store stays the same so it doesn't re-render, but also that it's not doing too much work. In this particular case, I've got some product on my state, which has some items, and the items have some children. Now imagine that we've got 1,000 items, and every item has 1,000 children. And what we're doing here is we're trying to find something within the children, so that means a lot of work. And we can memorize that so that we don't actually spend all of that computing power on, doing the same thing over and over again. Another issue might be if you return an object, because if you create an object, it's a new reference, and every single time it renders, especially if you're using immutable or something like that, it might be really worth memoizing as much as you can. Having said that, memoization, as everything, can also cause issues, so try to find like a middle ground somewhere in between. So what would be the best practices in terms of handling state? Because I mentioned of how you can handle props, but what do we do about state so that it's not tripping us up? The first thing is we found that setting local state is very, very expensive, especially if we're doing it for reasons that are not entirely valid. A typical awful example is in component.update, you're doing set state. That essentially means that your component just rendered, and based on that, you are re-rendering it again. So we definitely want to do this just once. So ideally, you can use get-derived state from props instead of using component.update or something like that. But usually, we change the inner state. Well, not usually, but quite often, we change the inner state based on the props that we just got. And quite frankly, there is no need for the component to handle this. We tend to have map state to props around our components. We tend to have different ways of passing the props down. So it's better for the wrapper to handle this. So even better, don't do anything in the component. Don't set local state at all. And as I said, if we don't have to set it, please don't. So in this case, we only want to set state to update it on click if it hasn't been updated already. So we actually started putting these if statements into a lot of places so that we managed to sort of lower the amount we are re-rendering for that as well. Ultimately, what is even worse is setting Redux state. So I told you not to set local state, but I will tell you now not to set Redux state and rather set local state if you have to do some state setting. The reason for that is that dispatching any action through Redux state is very, very expensive. If you have a huge Redux state, it will take time. I think we measured 3 seconds for one action to be dispatched from start to finish, and that is action that has no reducers in it, or like it doesn't actually do anything. It just takes a long time to go through all the sagas and all the reducers just to do nothing. But also quite often, if it does do something to the state, it means again that all of the connects are rerun, etc., etc. So we try to not set anything in Redux state unless we really have to, and that means that if you have to do something that's relatively local, just do it locally. That way, you are not going to be re-rendering the whole app as well. You will only affect a limited space. So always use local state over Redux state if you can. We also found that, for example, on our application start, we were dispatching some 20 actions. That was sort of like an organic growth, when you get, another ticket in Jira and you think, oh, I know, we already dispatched these 3 actions, I'll just add another one. And over time, it just grew to like 20. And that was getting really out of hand. Nobody understood what it was doing. And it was this like spaghetti monster. So we spent some time trying to figure out what it was doing, and then we batched them all up. So instead of dispatching 20 actions, we now just dispatch 1, and different sagas can react to it as they see fit. Equally, I don't know, for example, for trucking, we quite often used to dispatch actions that were separate from other actions. So as much as possible, just set everything with one action if it's happening around the same time. Then we had a huge, huge issue with connecting state, because at the beginning we thought that it would be less performant if we had a lot of connects around our application, because JSX, I don't even know why we thought that, but we made this assumption that if we have one connect on top of the whole application that gets all the props we need, we can then pass them down. That's how we got those components with 20 different props that grew like really difficult to manage. But also it meant that if there was like this component down here somewhere on the right that needed to update when there was an update to a name, we would need to update the whole tree instead of just that one local place. So we spent ages refactoring all our screens, putting the connects to the lowest possible levels, because that way we only changed the state that we actually cared about for those components that we cared about. This is a joke, but a lot of people thought about it seriously. Like, yes, MobX solves a lot of these issues because it handles updates to state completely differently. So a lot of what I just said would not apply to MobX at all. Having said that, I don't think it's a very good idea to like change your whole application infrastructure to improve performance. There are probably easier ways to do it. So for the JavaScript side of things, the general conclusions are, it's nearly always the JavaScript. I used to have it's always the JavaScript, and then someone told me they actually had a lot of problems in UI thread. So just check in on the performance monitor, and you'll see very quickly what thread is struggling. Always measure before acting. As I mentioned with the connects, we made an assumption a year ago that was based on absolutely nothing, just like an idea or gut feeling. And then it causes a lot of issues. So always check what the actual problem might be before doing anything with it. When you're writing your JavaScript code, and this is useful for web and React Native, think about how the reconciliation and state updates work. It will save you a lot of headaches later on. Don't assume that it can just handle it all, because it's true that it can handle a lot of stuff. Like React, especially on web, can process all these reconciliations very quickly. But if you think about it to begin with, you will then not have to refactor everything later on. And last but not least, memorize. It's not important to memorize everything, just memorize the things that you feel might be very heavy. Now for the native-only side. So everything that I was talking about until now was about JavaScript. But now I want to talk about the native-specific things, because that's actually the main stuff that I've been dealing with over the last few months, and I learned a lot of very cryptic pieces of knowledge that I never knew I would need. The first thing is animations. In our particular case, we didn't actually struggle with animations too much. And whenever we did, it was either due to the fact that we were doing something stupid in the JavaScript thread, or that we weren't using the native driver. So this is literally the animated library from React Native. And all you have to do is say use native driver true, and suddenly it's much more faster. It's like magic. There's also reanimated library, which a lot of people I know are using, but I find it relatively difficult to use as compared to this one, and we didn't find that we actually need it. I'm sure that there are apps out there that will benefit from it greatly, but you can just try this thing out to begin with. Then, this has literally been like my life for the last 2 months, is thinking about inline requires. There is this whole thing where essentially when you package your React Native application, you create a JavaScript bundle that has all of the code in it, and that involves even styles and images and all of this stuff. And if you're using the import syntax on the top of your files, what happens is everything gets bundled together. And if you have a complex application, it will become huge and very, very slow to load. So what we are starting to do now is using inline requires, especially for native modules, for pieces of code that are really, really long, especially for some of our sagas that we know are not going to be used for a while. We started doing that a lot. And last but not least, for images, because images do get bundled with your main application. So it's really beneficial not to put them directly into the main bundle. All of this, like putting things into inline requires, is not going to help unless you're using RAM Bundler. It's a sort of different way of packaging your JavaScript. It is included in React Native. In React Native 59, it comes really out of the box, so you just flip a flag and suddenly it works. Again, it's like magic. You do need to like do some other things, but there is a very nice tutorial on the React docs, so you can find it easily. And we found, for example, that when we inline required all of our images and switched on RAM Bundler, our bundle size was suddenly 150 megabytes less. That means that the memory that we're consuming when we turn on the app is 150 megabytes less, which is great. Because if you run a normal React Native plain Hello World application, you will see that on some Android devices, it's eating on its own maybe 280 megabytes. Considering that a lot of Android phones have limit 256 megabytes for an application, that is a bit of an issue. So you can increase it to 512 quite easily, but that's kind of the amount that we're dealing with. So reducing the memory consumption is always a really handy thing to do. Then there is another thing that I mentioned, that's lazy packaging. That's something that I very recently discovered, and it's super useful for native modules. Having said that, it doesn't even exist in React Native documentation yet. There is like this one article that you can find about it. But the idea is that we don't need to load the native packages to begin with. They are what actually slows down the startup of the app so much. We found that maybe 2/3 of our startup time is spent on starting up these native modules. So inline requiring them and using lazy packaging is really the way to go. I'm sure if you Google it out, you'll find out what I'm talking about. And if not, you can definitely get in touch with me after this talk. But inline requires are the way to go. Use them everywhere. Then there is this thing with, like, when you go to native as a JavaScript developer, you need to start dealing with tools that look like this. This is the Android Systrace, and it's super cryptic. But the important thing when you look at any Systrace is this green thread, which is MQTJS, and that is the JavaScript thread. We found that that's very often the place where there are problems, and you can quite easily debug all kinds of things, seeing what CPUs are being used and how you can improve it. This is especially useful if you need to prove that what you're doing is helping on your performance. So if you compare the systraces over time, you will see either them getting better or worse. And you should also use profilers, which comes out of the box with Xcode and Android Studio, and they are sort of nice graphs that show you memory leaks and that kind of stuff. There is one last thing that I found in our team a little bit controversial. We started using React Router Native to begin with for navigation. And that was because we were web developers. We've always used React Router. We were familiar with the syntax. We assumed that we can reuse a lot of code from web in our React Native app. So it seemed like the best option to use React Router Native. The problem with that is it's actually not native at all. It is all done in JavaScript. It's all done through state. So the moment you navigate somewhere, it's super slow. And we got to a point where you would like click to navigate somewhere, and then you would wait, and nothing would happen for maybe 5 seconds. Like even I started thinking there must be a bug in the application, but no, it was just really slow. So we spent 2-3 months when all dev work stopped, and we had to rip out this React Router Native. And instead, we used React Native navigation. Most of community is using React navigation. Over the last year, I'd say it became really, really quick, especially with the last version update. It started using some of the native bits like stacks, etc., that make it really feel nice, while it really follows nicely the paradigm of React Native. We are using React Native navigation, which is also very good. It's pretty much done in native. Its problem is that it sort of hijacks the React Native host. So if you then look into the code of like the Java bit, it's a little bit scary because it sort of like they sort of like copy pasted the React Native code into their own host, and it goes out of sync with the main React Native quite a lot. So it's a little bit of a wild ride with it sometimes. So I would recommend React Navigation if you want to choose good routing. So the TLDR really is optimize your app wisely, always measure first, always make sure that you know why you're doing things. The tools that I have pointed out to you, especially the performance monitor and the performance tab in Chrome, are very easy tools to use, and they are very easy to read as well. If you don't understand this performance stuff like I did a few months ago, they are very easy entry points. And yeah, that's about it. I hope it helped. Thank you.